Okay, this is just an aside from what we've been doing, and the thing is about how do people create problems. For one way they do that, they just look what other people are doing, and there's nothing wrong with that. It's for the most part, these problems are somebody else's problems. It isn't like I thought about this. All right. Now, certainly, why is that? They really do work nicely, but they often confuse people, myself included. So this question over here says find the infinite sum or show that the series is divergent. So my hope is it's divergent because it would be the easiest thing to do. So before I do anything, I want to write down, what S looks like to me. And I do see the decimal. The decimals kind of bother me. So I want to write the way it appears to me. It appears that it's 1 over 100. That looks better to me than the 0.01. The next one looks like 2 over 1,000. And the next one looks like 3 over, let's see, 10, 10,000. I think you're getting an idea that this has a very nice pattern to it. 4 over 100,000. And I can say yada, yada, yada. All right? Let me just make sure that's true. There's 1 0, 2 zeros, 3 zeros, 4 zeros, 5 zeros, 6 zeros, 7 zeros. Yeah. Things are working as advertised. I'm going to have my eraser out, and I kind of see the pattern at this point. Again, I'm wondering, can I take the sum? So to do that, I want to write down what the term is. I'm going to write down AN. I'm going to say it appears to be, well, just look at the top number. It's fairly simple looking at the top. It's, 1, 2, 3, 4. And yeah, it's very simple. I'm just going to say N with the understanding N is starting at 1. So N greater than or equal to 1. All right? What's on bottom? It's power of 10. So I'm going to put that over here. And it's somehow related to N. And it looks like it's 1 more than that. So I'm going to say N plus 1. Let me just make sure that works. A1 would give me 100. A2 would give me 1,000, so forth and so on. Look, pretty good. Then the question becomes what's the series then? Well, the series would be this. N equals 1 to infinity of N over 10 to the N plus 1. And we got a simple test for that, a ratio test. Let me just go through that kind of quickly. So I'm going to do the ratio test, RT. And hope for the best. What do you get? Limit as N goes to infinity. N plus 1. That's going to be N plus 1 over 10. That's going to be N plus 2 now. And we're going to divide by AN, which is multiplied by its reciprocal. 10 to the N plus 1 over N. Well, let's keep going. Limit. N goes to infinity. I can move the absolute value thing pretty easily. And you get N plus 1 over N. And then you get times, let's see, that's going to be 1/10. Well, as N goes to infinity, the N plus 1 over N goes to 1. And 1 times 1/10 is 1/10. So what do I know about this over here? This is a convergence series. I may not know what its sum is, but I know it converges to something. So what I want to do is talk about, I was hoping for that to be a divergent series because it would end there. What I have to do now is I got to start thinking about what it is. And one way to do that is just simply say it's probably related to something that you do know. And looking at it, a limited idea of the series that I do know, I'm going to say it has something to do with the geometric series. All right? So I'm going to write that down for you. The geometric series, it's something you probably should know at this point. 1 plus x squared plus x cubed plus yada, yada, yada. And again, my belief it has something to do with that. Now, this is going to be, certainly a convergence series where the absolute value of x is less than 1, proper fraction. Now, of course, if it's 0, looking at it, 0 is fine too, but anything between 1 and minus 1. So looking at I still don't really see what I'm expecting to see. So what I'm going to do is I'm going to differentiate it, because then at least I think I'm going to see those numbers like 1, 2, 3, so forth and so on. So let me write a little bit differently. Right, this is 1 minus x to the minus 1. This is 1 plus x squared plus x cubed. And again, I got suspicion that this is going to work out. So what do you get over there? It's going to be minus 1 minus x to the minus 2 times minus 1 equals 1 plus 2x plus 3x squared plus 4x cubed. Well, I get the idea. There's a pattern there. So I am seeing the numbers I want. 1, 2, 3, 4, so forth and so on. I'm going to simplify a tiny little bit. And this would be 1. And this would be 1 minus x squared. And that's going to be equal to 1 plus 2x plus 3x squared plus 4x cubed. And now my problem is I'm trying to get that, the number I want. And really it has something to do with, I need to pick an x that produces this thing over here. I definitely got the 1, 2, 3, 4. Now, in other words, I have the top certainly, right? I have that. That's a definite fact at this point. Let me just go backwards on it. So I got this part of it. But I'm looking at this x and I'm wondering, it's starting at, that's kind of weird, right? It's like, I think I could do it by picking an x, and if I pick 1/10, well, that's not going to do it for me. Because if I start at 1, I should get a 10 at the bottom, right? So let me multiply both sides by x and see if that helps at all. So it's going to be x over 1 minus x squared. That would give me x plus 2x squared plus 3x cubed plus 4x 4. And again, if I pick 1/10, it's still not going to do it for me. So I'm going to do x squared now. I'm multiplied by another x, so I get x squared. 1 minus x. Again, I'm trying to get this pattern over here. Picking a number that's easy. When I say an easy number, somewhere between 1 and minus 1. Certainly it's going to be a positive number. What do you get there? You would get x squared. Let me put the 1 in front of it. Plus 2 times x cubed. Plus 3 times x 4. Plus 4 times x 5. By the way, this goes on forever. Sorry about that. Now, if I pick the 1/10, and I'll write that down for you. If I pick 1/10 on top, again, I'm going to let x equal 1/10. Certainly in this category over here. Let's see what we get. You get 1/100th on top. On bottom, you're going to get, 1 minus 1/10, it's 9/10. Whoops, this is squared, sorry. And 9/10 when squared is 81/100ths. Now again, I'm trying to make sure I get the right sequence of numbers over here for the series. So what would you get for the first term? You get 1 over, 1/10 squared is 100. What's the next one going to be? 2. Well, when you cube 10, you get 1,000. Well, things are looking good, right? 3 over 10,000. I think you get the idea. Are we getting the numbers we expected to see? We're getting the numbers we expect to see. 1 over 100, 2 over 1,000, 3 over 10,000, yada, yada, yada. So I know my sum. Let's just simplify a little tiny bit. And what am I simplifying? I'm simplifying this. I'm not adding that together. I'm just saying I got the pattern to it. What does it give me? 1 over 81. So I'm expecting this thing to be a convergent series that we did by ratio test. And I'm saying it's 1 over 81 now. So that's my conclusion. Again, if you look at the notes, we go through that. We say it's 1 over 81. Something else, in addition, said to that, 1 over 81 is a rational number. And if I were looking at that number, I would expect a repeating decimal on it. I would. What do you mean by that? Like, for example, a number like 1/3, it's a rational number. What do I get over there? Well, it's a repeating decimal, something like this over here. Like if I put down, 1/6, so forth and so on, 1/9, whatever, I'm expecting some repeating pattern to it. Let me just erase this over here. And let's talk about if I can figure out the repeating pattern to it. So let's write this down. And remember we have 0. Let's review ourselves. Let's see. 0, 1. and then 2, and then 3, and then 4, and then 5, and then 6. What am I doing over here? I'm adding these things together. That's all I'm doing. And then I get 7, and then I get 8, then I get 9. And the problem with the next one, again, what I said the problem with the next one is it's 2 digits. So I got to kind of add it on. I got to add that on. What's the next one going to be? Again, I'm not putting all those zeros down there. It's going to be this thing over here. What's the next one going to be? This one over here. Again, I'm just trying to get a feel for it. That's all I'm trying to do. Right? I'm going to see if I can see a repeating pattern over here. Now, what do I notice about this over here? 1 plus 9 is 10. So I'd carry the 1 here, and I get 9. So let me write this over here. 0.0123 4, 5, 6, 7, not 8, but 9. And then I get the 0. All right, remember what I did. 9 plus 1 is 10. I get the 0, carry the 1. Then what do you get? You get, let's see. Let me see if I did this right. 1, I got 0, I got 1. I think I made a mistake somewhere. Oh, I'm sorry. I wrote down 12 when it's 11. Sorry about that. Whoops, I went too far with the erasure there. It's 10, 11. Did it again. This would be 11, this would be 12. So how'd you know you made a mistake over there? I'm looking for a pattern that I actually know the pattern, by the way, for doing it. So 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. I think you get the idea. And so what's the idea over here? You know, the next one is going to be 4. And why is that? You'd have 1, 4 here. Next one's going to be 5. And then you sort of understand that there will be repeating as you go along this over here. And what's the repeating pattern going to be? It's going to be this over here. Right? That's the repeating pattern. How would we write that down? Right? Now, going back to grade school, at least where I went to grade school, we wrote that with bars. So 1 over 81 would be 0, 0, 1, 2, 3, 4, 5, 6, 7, not 8, but 9. This whole thing repeats itself. That repeats itself over and over and over again. I kind of want to remind you that, again, not the easiest thing in the world to do, but I want to point out you did a lot of repeating decimal problems in prior courses. Let me get rid of this. I'm kind of convinced that this is going to give me 1 over 81 now. All right? Now, could I have made a mistake? Of course I could. I want to claim to you what you did in, like, for example, lower level math courses. If they told you, this number over here, 0.3, repeat, what you would have done was you would have multiplied it by 10, because that's the length of the repeating pattern. Again, 1 decimal place is 10, 1, 0. What would you get? 3.3. What do you do now? You subtract. And 10x minus x is 9x. And 3.3 repeating minus 0.3 repeating would just be 3. Divide both sides by 9. What do you get? 3/9, which is 1/3. Which I knew that anyway. Right? I'm sure you did as well. This one's a little more difficult because to me it's difficult because it's like a lot of counting. So if I were to put this one down, and let me write it down for you. X equals 0.0123 4, 5, 6, 7, 9. Put a little bar over there. I really don't like the way that looks because I need to multiply by something, right? And what do we need to multiply by? I need to multiply a certain number of digits. Oh, by the way, the next digit after this one is going to be 0, blah, 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 blah. 1, 2, 3, 4, 5, 6, 7, 9. It's going to be missing the 8. So I'm not going to write that down. I'll erase it now. Question is, how many places do I need to multiply by? We'll take a look at it. 10, 100, 1,000, 10,000, 100,000, 1 million, 10 million, 100 million, 1,000 million. All right? Now let me just count it up with a number. I don't like writing down number, all the zeros down over there. So let me just go backwards a little bit. And let me point, we did the 0.3, that was pretty easy. I multiplied by 10, one place, right? 10 to the 1. So 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6, 10 to the 7, 10 to the 8, 10 to the 9. So I can multiply both sides by 10 to the 9. And what would you get? Well, you're going to get this. 1, 2, 3, 4, 5, 6, 7, 9. Point. Here comes the tough one. Point something. Point what? 0, 1, 2, 3, 4, 5, 6, 7, 9. And this keeps repeating. What I'm going to do now is subtract. All right? So if you subtract it, I'm going to do this over here. It's going to be 10 to the 9 minus 1 times x equals 1, 2, 3, 4, 5, 6, 7, 9. So I did it right. 1, 2, 3, 4, 5, 6. Yeah, I did okay. What's x? Let's write this down. 1, 2, 3, 4, 5, 6, 7, 9 over 10 to the 9 minus 1. Now, someone could say, that's crazy, that number there. That number is supposed to be 1 over 81. What I want to suggest, though, is that you try this on your own. Try to reduce this number. And it's going to reduce to that. Thank you.